So welcome to this new section, and in this lecture, we are going to learn about transmissibility. Transmissibility. So here, the transmissibility is equal to transmissibility is equal to effect by cause. So we can divide transmissibility into two types. We can divide transmissibility into two types. The first one is force transmissibility, and the second one is motion transmissibility. Now let's talk about the force transmissibility. So let's cover this thing first. Sorry, this is force transmissibility. So let's talk about force transmissibility. So the force transmissibility is defined as the ratio of force transmitted to the supporting structure to the supporting structure to the disturbing force to via the disturbing force acting on the system. Acting on the system. So we can say that it is the ratio of, so it is the we can say that it is the ratio of amplitude of forces. So we can visualize like this thing. Suppose there is a machine mounted on any surface. So this is the working machine. Suppose this is the working machine here, and this is the machine, and there is a force transmissibility from machine to the structure. So and the diagram can support the definition is something like this. Suppose this is a machine mounted to spring system and a damper system, and this is the base, and this is the force transmitted from machine to the structure, and this is the force F naught sine omega t. So we can define the force transmissibility is equal to Ft by F naught. So this is the force transmissibility. Now moving to the next topic, that is the motion transmissibility. Let me erase this thing first. Now let's talk about the motion transmissibility. So in this case, the forced vibration due to the excitation of support, motion transmissibility is defined, motion transmissibility is defined as the ratio of amplitude of the mass or body to the amplitude of base excitation. So you can see, suppose this is the system, this is the machine attached to the spring system and the damper system here to some base, and this is the effect. And this is the cause, and the displacement is the effect. So we can define the motion transmissibility as the ratio of x upon y. So we can define this term, sorry, this is y here, this is y. So this is called transmissibility or transmission ratio So we can write the simplified equation. So let's write the simplified equation for this case. Okay. So the transmissibility is equal to under root of 1 plus 2 zeta r whole square divided by 1 minus r square whole square plus 2 zeta r whole square. So this is the transmissibility. Now let's analyze the force transmissibility. So this is our last topic of this section. So let's analyze analysis of force transmissibility. Now just consider this given system. So just consider this given system. This is the machine, this is the spring system, and this is the damper system mounted to some base, and this spring has the spring constant K and the damping coefficient is C. There is a transmissibility force Ft, and this is the counter force, that is F naught sine omega t. So here is the Ft is the force transmitted to the foundation, which will be the resultant of spring force and damping force. So let me write it. Ft is the force transmitted to the foundation which will be the resultant of spring force and damping force. So from parallelogram law, Ft is equal to spring force under root of spring force square plus damping force square plus 2FdFs cos theta. So here Fs and Fd are the amplitude. Fs and Fd, Fs and Fd are the amplitude forces of spring and damper. So we can write the equation of motion. Let me write this thing first. So we can write the equation of motion as mx double dot plus cx dot plus kx is equal to f naught sine omega t. So the solution of this equation, the solution is x equal to a dot sine omega t minus phi. So this is the equation of the displacement. So x dot, that is the velocity, is equal to a omega. So we have to differentiate the x with respect to t. So x dot, that is dx by dt, equal to a omega cos omega t minus phi, and x double dot is equal to minus a omega square sine omega t minus phi. So substituting the value of this x dot and x double dot in this equation, we are going to get a new equation, that is let me rewrite this whole thing. Minus ma omega square dot sine omega t minus phi plus c a omega dot sine omega t minus phi plus pi by 2 plus ka sine omega t minus phi is equal to f naught sine omega t. So after further simplifying, bringing f naught sine omega t to this side, we are going to get f naught sine omega t plus ma omega square sine omega t minus phi minus ka sine omega t minus phi minus ca omega dot sine omega t minus phi plus pi by 2 is equal to 0. So this is the simplified form for this whole thing. So this marks the end of this section. So for now, thank you.